Citrus is a language and user interface toolkit that is designed to simplify the creation of graphical editors for structured data and code. Creating a Citrus editor involves describing the data types to be edited and designing their corresponding views. We will demonstrate this by creating a to-do list editor. We begin in the Citrus class editor by creating a language called to-do, which will consist of 3 classes of data which we drag from the toolbar at the top. We'll name them to-do item, to-do list, and to-do doc. Because this editor was created using Citrus itself, it exhibits many of the features that Citrus makes possible. We'll give to-do item 2 properties by dragging them from the toolbar. One will be a boolean named done, which starts as false, and the other will be a text string named what to do, which will start as an empty string. We'll use Citrus's support for property restrictions to restrict what to do to a regular expression that disallows whitespace characters. Notice that as we type, the editor parses our keystrokes and creates Citrus code. The second type of data, to-do list, will be a subclass of to-do item. This will allow our editor to contain nested to-do lists. In addition to the done and what to do properties it inherits from to-do item, we'll add a list of to-do items named items that starts as a new list containing a single to-do item. Our final class, to-do doc, will store a single to-do list as the root of the document. We will also add a property called hide, which will indicate whether the editor should display completed to-do items. We'll use this property in our view of a to-do item, which we'll create now using the Citrus Interface Builder. Our to-do item view will use a checkbox and text field to represent the done and what to do properties. The Interface Builder chooses a property of the appropriate type for each widget, which we can always change in the Children panel. To arrange these 2 widgets, we'll change the view's layout to a horizontal layout. Notice that as we modify this expression, the builder reevaluates it and updates the preview in the upper left. To fit the view around this horizontal layout, we'll write 2 expressions using the methods last child's right for the width and tallest child's height for the height. We change the equal signs next to the 2 properties to arrows to indicate that these properties are constrained to these expressions. Recall that we added a hide property to the to-do doc to hide completed to-do items. We'll use this property in a constraint to determine the view's scale. The constraint expression will return 0 if both the to-do item's done property and the hide property of the to-do doc that contains the to-do item are both true. Otherwise, it will return a scale of 1. To find the to-do doc that contains the to-do item, we use the owner-of-type method, which searches up the data hierarchy for an object of a particular type. The last thing we need to define are interaction techniques for adding and removing to-do items in to-do lists. To do this, we'll add 3 behaviors, which will respond to carriage returns, backspaces, and tabs. Each returns true to indicate that the view consumes the event. Note that the code dragged from the toolbar is simply a template for responding to a keyboard-typed event. It could easily be typed by hand or modified to respond to a different event from a different device. If a carriage return is typed, we insert a new to-do item after this one. To do this, we access the owner of the model of this view. The model is the to-do item the view represents, and the owner is the object that contains the to-do item, in this case, a list. We handle the other 2 keyboard events in a similar way. If backspace is typed, we will remove the to-do item from the list that owns it. If tab is typed, we'll replace the to-do item with a new to-do list. After also designing views for the to-do list and to-do doc classes, we'll have this editor. Just as we defined, typing enter makes a new item, and typing tab replaces an item with a to-do list. Clicking the Hide Completed Items checkbox changes the to-do doc's hide property, causing completed items to scale to 0. Citrus can be used to create a variety of editors. For example, one benchmark for comparing user interface toolkits is building a connected graph editor. We created this editor in just half an hour and about 60 lines of Citrus code. This is fewer than half the lines of code required to implement the same editor in the Amulet toolkit. In addition to basic user interfaces, Citrus can even be used to create code editors. This is a prototype of a Java code editor, showing a Java class declaration. Method declarations can be created with a keyboard shortcut and modified through direct manipulation. Statements, conditionals, and loops can also be added, just as with plain text code, but without the syntax errors. Combined together, the Citrus Language and User Interface Toolkit can greatly simplify the creation of a new class of graphical structured editors.